Now we could talk about solving trigonometric equations with extraneous solutions. So these are still going to be the single angle, but this is going to be something that we have to do some algebraic manipulation. And because we're doing some manipulation, we're going to have to check for solutions that don't make sense in the end. So if I'm given cosine of x plus 1 is equal to sine of x. Now notice there's nothing that I can really do to substitute anything here. I can't really just take cosine and make it into sine, in the same way I can't really just take sine and make it into cosine. So what I need to do is I need to find some way to give them some sort of relationship. Now I know that sine squared and cosine squared have a relationship. So what I'm going to do is I'm going to actually square both sides. So I'm going to take cosine of x plus 1 squared is equal to sine of x squared. Because remember, in algebra, as long as we're doing it to both sides, we're not going to change the equality. So what I'm going to have is cosine squared of x plus 2 cosine of x plus 1 on the left-hand side, because that is this foiled out, is equal to sine squared of x. Now, be careful here. I know that you guys have already taken an algebra class and you probably don't need this, but there are so many people that still evidently don't try to use their pens correctly. So they think that cosine of x plus 1 squared is going to be equal to cosine squared of x plus 1 squared, and this is not true. Okay, so be careful. When you do have something like this squared, you do need to FOIL it out. So again, if you're having trouble getting this left-hand side, it's because this is actually equal to cosine of x plus 1 times cosine of x plus 1, and you need to actually multiply them out. All right, so that takes us here. So we get the left-hand side is equal to sine squared of x. So then what I'm going to do is I know that sine, since the majority of my stuff over here is cosines, I'm going to convert my sine into cosine using the Pythagorean identity. So this gives me cosine squared of x plus 2 cosine of x plus 1 is equal to 1 minus cosine squared of x. And then what I'm going to do is I'm going to move my right-hand side over to my left-hand side by subtracting 1 and adding cosine squared. And what that gives me is 2 cosine squared of x plus 2 cosine of x is equal to 1. And then I'm going to factor out a greatest common factor here, because I notice that I have 2 cosine and 2 cosine, meaning I can factor that out as a greatest common factor, leaving me with cosine of x plus 1 after I factor out that greatest common factor. And again, from here, I'm given 2 different factors that I can use the zero product property for. And I'm finding that my x values are going to be pi over 2, 3 pi over 2, and pi. Now, the reason that I had to be careful with this is this portion right here. I squared both sides. And when I square both sides, that means I can get what are called extraneous solutions, or solutions that are not actually going to exist inside of my solution set. And that's just because of the way that this was manipulated. So what I need to do is when I do something drastic, so very drastic like squaring both sides, what I need to do is I then need to go through and check on my solutions. So let's actually check our solutions here. So checking my basic solution, I get cosine of pi over 2 plus 1, because what I'm going to do is plug those back into my original formula, just like you would in any sort of algebra class. I'm going to get cosine of pi over 2 plus 1 is equal to sine of pi over 2. Cosine of pi over 2 is equal to 0 plus 1, and then I get sine of pi over 2 is equal to 1. So that solution is going to check out. So when I go to write my general solution, I'm going to write pi over 2 as one of my general solutions. So these are just going to be checking our basic solutions. You would still need to write them as general solutions. So let me check my second one. So I get cosine of 3 pi over 2 plus 1 is equal to sine of 3 pi over 2. So cosine of 3 pi over 2 is going to be 0. And then I have plus 1, and then I have that equal to 3 pi over 2 and sine, but sine is equal to negative 1. So this gives me 1 is equal to negative 1. Since this is not true, this is not going to be part of our solution set. So this is going to be one of those extraneous solutions that I'm not going to include. And the last one I need to check is cosine of pi plus 1 is equal to sine of pi. Cosine of pi is negative 1, plus 1 gives me 0, which is the same thing as sine of pi. So my generalized solutions are going to be a generalized solution of pi over 2 and a generalized solution of pi.